everyone. I'm Larry Gordon. I work at Westfield Retail Solutions as a principal engineer. This talk is about Performant 2D WebGL animations with PIXI.js. At work, let's see, how can I say this? I deal with a lot of WebGL, I guess. Not directly, but mostly through PIXI.js right now. And the product that I work on is a mapping solution. So originally there was a vendor out there, and they were doing it all DOM-based, and came in, decided to kind of rewrite the whole thing because I thought that the performance could be a lot better. Went through a lot of different frameworks and stuff, and ended up choosing PIXI.js because it was really highly performant just with 2D animations. Really simple. I come up from like a really old Flash background. Started doing Flash development in '99. So I went through that whole like range of development fun. And one of the things that I liked about PIXI.js, it was very similar to kind of like Flash development, or if you've ever done any type of Canvas 2D work, the drawing APIs are fairly similar. One of the things that, didn't want that one. One of the things that that really wanted to try to achieve when like re-rendering maps for us, and the maps that we render, they're primarily based for indoor positioning, right? And when I say Westfield Retail Solutions, I'm really talking about like the Westfield malls right now. And so like the one in San Francisco, World Trade Center, London, things like that. And so some of the things that we're starting to roll out is like blue dot positioning, and being able to get like anywhere as close to like maybe 2 to 3 meters of accuracy, like where you are in the center. And so in order to kind of help like propel us forward a little bit more without having to support like 4 different frameworks, I decided, let's just do this WebGL. So what I'm going to do is I'm going to jump out of that. So one of the things that I wanted to talk about was some of the stuff that I ended up coming across that was just really kind of difficult to kind of grasp right away, but then it's like once you kind of overcome some of the hurdles of trying to just achieve 60 frame per second animation, it's like it just sticks with you. So right here, I've got approximately, let's see if I can find my cursor. I've got about almost 40,000 circles on the screen right now. And so it's like the performance is okay, but you can see is like as soon as I kind of start it up and I start moving around, you can see the frame rate in the upper right corner. I don't know if you guys can see that very well. But it's dropping a lot of frames. It is not getting 60 frames per second. And because this is probably like a higher end machine, it's like you're not really noticing very much in the way of the animation lagging, right? It's still like fairly smooth. But, we can do better. So let's see. I believe that this built correctly. Hold on. Oops, didn't stash. Yeah, this should be the correct one. Let me go with the smaller window. Okay. So right here, I'm pretty much almost holding at close to 60 frames per second. I'm dropping a frame here somewhere. I imagine it's probably due to garbage collection. I didn't have time to actually find it and see what was going on. But one of the big key differences here is the data is being captured the same exact way, right? It's being captured on mouse movement, right? But the difference is that when you decide to actually draw it or actually run the commands in requestAnimationFrame. So just to kind of like start real quick, who all is familiar with requestAnimationFrame? How about this? Anybody not? No? Okay. Okay, so requestAnimationFrame is basically a loop that the browser does, right? That the browser engine does. And so what it does is that if it runs smoothly, you can attach a function to the requestAnimationFrame, and it'll execute anything that's in that. And so the requestAnimationFrame runs that cycle. It runs once. It tries to run once, 60 times per second, right? Now, if you do anything to cause one of those instances of running to actually take longer than the 16 milliseconds that it would take to actually execute, then you're going to start dropping frames. You're going to see slowdown, things like that. So one of the big things that ends up happening is when you're capturing user input happens really fast. So things like mouse movement, things like scroll events, and so they can happen many more times, like multiple times within 16 milliseconds, right? And so if that happens and you're calling like render a bunch of times, or you're trying to do recalculations a bunch of times, you're going to end up getting a bunch of jank that happens, and you start dropping frames. And so one of the best ways in order to kind of prevent this, and the big difference that this version is doing versus the first version is that you try to buffer anything. So anything that is considered like user input, anything that is running on something that is not on requestAnimationFrame, it's like you want to buffer it, right? And I'll go into the code in a second. But what is happening here is like as I'm moving around, there's an engine behind this that's just ticking every single requestAnimationFrame, right? And all it's doing is polling for values, right? Which is completely independent of me moving around this mouse cursor, right? And so, like, you can see that, like, if I sit here and hold on, try to do it without moving my finger, you'll see that the frame rates, you'll see it just kind of pause and stop up in the right corner, that little graph. And so what that's doing is that's basically telling the engine just to stop and pause. You don't really have to do anything. There's no values that are changing or updating visually. So it's like you're basically displaying a JPEG, and there's no sense to cause the machine to re-render anything or the browser engine re-render anything. But like whenever I'm holding this down and I'm moving around, the requestAnimationFrame engine starts, it runs, right? And then on the other side, there is listeners listening to my mouse events and just capturing and buffering the values, right? And so what happens is that when the requestAnimationFrame runs, all it's doing is saying, let me go look up what the buffered value is for the XY position of my mouse, right? Because at any particular time, it basically gets locked at that point. We figure out what that value is, and then we just do execution based off those numbers. And so because of that, I can still be pummeling the buffer, right, with mouse events. But the calculation doesn't care, and the calculation and the redrawing doesn't care, because it's just gonna grab the values from the buffer once and then do its thing. And then when the next requestAnimationFrame pops around, then it's gonna grab the next set of buffered values. And it doesn't care what the values were in between there, right? Because you may have like multiple mouse events go off, and the actual XY value of the mouse may be exactly the same, right? But it could have just been fired a bunch of times. So, in some ways, it's like you can call this a buffer, or you can call this kind of like debouncing, right? But it's like we're not debouncing based off of time. We're kind of like debouncing based off of the request animation frame, right? So, like taking that into account, I'll kind of show you the product I've been working on. So, the thing here is that right now it's like you'll see like a little red thing down there in the lower left, right? That means that the little red light in the lower left-hand corner means that the engine's not running. So if I click and I hold down the mouse, then you can see it turns to green. That means that the engine's running, requestAnimationFrame's running, and it's actually capturing values. Right now, it's not really doing anything. It's just kind of sitting there, right? But if I click down and I start moving around, right, and I'm just panning it, right, which is basically taking like a JPEG and just moving it around, right? But then it starts to get a little bit more interesting, like when you start doing like rotation, right? And so what we're doing here is like, okay, well, we're taking the rotation value, we're buffering it, and we're taking each of those, we're taking that value and propagating whatever like the rotation is, applying a reverse rotation to all the labels. And you can see it's like, I'm holding pretty good at 59.9 frames per second, which is kind of weird. But it should be close to 60 frames per second, right? Same thing with like zooming in, zooming out, stuff like that. So like one of the things that you get with like zooming, right? It's kind of hard to control that. It's like there's nothing smooth about it. It's like every time you click like a scroll wheel, you get like one event that gets fired off. And so people can go and scroll really fast or scroll really slow. So you kind of have to kind of like buffer that out and kind of spread that out in order to kind of try to get as smooth as possible. But for some reason, even though that I'm going like this and zooming in and out, and it's doing a full redraw and scale and everything, it's like the browser still wants to drop frames for some reason, because just the act of me doing that is just causing the browser to drop frames. Yeah, so the question was, is the map vector or is it a raster image? It started off as vector, so it started off as an SVG whenever I consume it, and then basically go through all the drawing commands and convert it using the PIXI API into all the shapes that you see there, and just kind of like reapplying all the layers and then a bunch of other logic, to define whether something is. Yeah, it's so underneath. So using the PIXI.js drawing API, underneath that is the WebGL code that basically they've got a bunch of GLSL and shader code that takes all the coordinate information and drawing information that you give it and basically dumps it over to the GPU. Yeah, so the last question was, it's not just a texture, it's just straight to the GPU from the drawing information. And yes, it is. It's not just a texture. So it's rescaling, it's recalculating, like all the text, like everything that you see like sitting on top of the map is like 100% WebGL. Like this is the only thing that is like DOM, that is like this, the thing in the upper left corner. That's the only thing that's DOM. And this little guy down here. And so, yeah. So, going back to this guy, it's like, I kind of wanted to pummel this a little bit. So, I chose a high number of objects and they're just circles. They're circles with a texture, with a circle texture that, with like a 0.2 alpha transparency, laid out in a big giant grid in what it would fit in. And, there's a little bit of calculation to kind of figure out like where the mouse is and then push it away from whatever its origin point is. And I can kind of go into the code there if you want. Let's see. So I guess let me show you the janky code first. Okay. So like, let me see if you can see this. Is that good enough? Can you see it in the back? How about that? Cool. Okay. So, so for this thing, I decided to try, what was it, nuclei.io. It's kind of like a bootstrapper application thing. It uses Webpack underneath and stuff like that. So, so I just instantiated it up, and basically it uses Babel underneath. So we've got ES6 here, syntax, and we're just pulling in a couple of local classes here, and then some stuff from PIXI.js, and then we're also including, just a little bit of CSS to kind of just, wrap the wrapper. Also, in the first iteration that I did with this, I originally tried, you probably can't see that well. I originally tried it with just like a 800 by 600 box, and was centering it in the page. I was like, oh yeah, I'll just use Flexbox. And as I was like resizing the browser window, it was causing all kinds of drop frames. It was like the repositioning of the canvas element within the page was just really super nasty. I was really surprised about that. So I decided to just go with kind of, the original thing was just kind of defining the width and height, and just kind of like doing a negative margin on the left right. And once I did like the old school hack trick of centering a div, then all that like window resizing jank kind of went away. But let's see. So in the map stuff, we're using PIXI v3. In this demo, which I'll give out a link to the source code on this, I'm using the latest version of PIXI 4. So they've changed some of the Surface API a little bit, not too much, but for the most part, they've made some advancements and stuff like that. But haven't been totally sure if it's like 100% stable yet, so haven't quite switched our stuff over to it yet. But for the purposes here, everything works great, so working with it. So basically here, it's like I'm kind of like initializing this engine. And the newer version of PIXI.js, it actually does come with a requestAnimationFrame engine. And it seems to work pretty good, but there were some specific use cases that I kind of like preferred working with on my end. And so I decided, just go ahead and give kind of like a variant of the engine that we use for our mapping platform. And so there's quite a bit of documentation here that kind of describes each of the variables and stuff like that. But the basics is, it's like, we check to see if the engine is currently running, if it's currently like in an update process. And that's kind of like the main thing, right? It's like we don't want to step on our own toes, because, if you have like a requestAnimationFrame engine, it's like it could be called to actually do like a render like multiple times from multiple different points. And in order to kind of like guard itself, it's like, okay, well, say you just did a you just clicked something, right? And that thing that you clicked causes 5 other things to actually change state, right? And those 5 things maybe would call like a render call, right? And so it would tell the engine, it's like, hey, go ahead and render. But since all of those 5 calls would happen in a single requestAnimationFrame, it's like they've all updated their state. It's like the engine only really needs to run the first request that it gets, right? So let's see. So like up here towards the top, it's like you've got like a couple of callback functions that you can subscribe to, like on update. So every time the engine updates, anytime the engine calls an update complete or update start event, You can remove those event listeners. And underneath, it's just using event emitter 3, just really simply, just to kind of manage those. So starting. So right here, it's like we're currently checking to see if the engine's currently running. If it is, don't worry about trying to start it, and don't worry about trying to call a requestAnimationFrame. But if it isn't running, then we are going to go ahead and call a requestAnimationFrame and give it the callback function within this scope for this private function called _RAF. And let me jump to it real quick. So all this guy does, and so the syntax might look a little bit weird, but what this is actually doing is that this is creating an arrow function that is bound to the class property _RAF, right? And so this prevents us having to do like a .bind on the function every time you call it, or sometimes what you may see like in a constructor, you may see like, you know, the actual function itself, and then, you know, maybe you're using the double colon syntax. You know, you may see something like that, or you may see something like that in order to bind. This, where are we at? This is another way of doing it, right? And so the weird thing is like, there's, with requestAnimationFrame, and just like with event listeners, there's no way to actually pass along your scope. So as soon as you pass it a function and that event listener actually fires off, the reference to this doesn't reference the class anymore, so you're kind of screwed, right? So this is the reason why you want to go ahead and bind whatever function that you're using for requestAnimationFrame, or anytime you're using add_event_listener on any type of DOM element, things like that. So as we jump into this engine, it's like what we want to do is, you know, it's like we've got this variable called requestID. We set it to null, and then we check to see if we're currently running, or if we're not currently running, has this run once parameter been called. It's like, you know, maybe there's just kind of like a one-off thing that, you know, we want to execute, and we just want to do a single render call without having to worry about like starting the engine and stopping the engine, things like that. It's like we just wanted to like step once, call all the update functions for everything that was listening to it, and just say, hey, okay, cool, everything's updated, then I can do a render, right? And it's, you know, if there's no listeners, right, like there's no sense of calling anything. So if there's nothing to be updated, it's like, you know, might as well just exit out, right? So this calls update, and with a timestamp. So this timestamp variable, this timestamp comes from requestAnimationFrame. And so it uses a what's called a DOM high-res timestamp. And so it's very similar to like date.now, but it's much higher precision. And so you can use that if you want to do like really fine-tune precision from like a previous requestAnimationFrame to the current one. So we pass that along to the update function, which all it does is it checks the current time. So here it's like this GetTime function is sitting up at the top, and really all it's doing is just buffering and checking to see if timestamp is null. So if it wasn't, then it just passes Performant.now, and you can see it right here, right? Where'd you go? Okay. So we set a delta time, and here it's like we go through a bunch of checks again, right? It's like we want to check to see if it's currently updating. So if for some reason this update function, since it's a public function, it was called, and it's previously like within this loop somehow because of some async operation, InUpdate is going to be true. So if it is, exit out, right? if request ID happens to be null, which means that requestAnimationFrame wasn't called upon requestAnimationFrame, right? Then like this is going to work, right? So InUpdate needs to be false. Request ID needs to be false. It has to have listeners, and the current time has to be greater than the previous time, right? So one of the weird things that can happen, like when you're tweening something, is that, and PIXI.js actually has some documentation in their ticker class internally, where with, say if you were to use something like TWEEN.js, and TWEEN.js has an update function, and you basically pass it like a timestamp variable every time you do a tick on a requestAnimationFrame, right? And what that does is that allows the thing that you're tweening, it allows to choose at which point to grab the interpolated variables, right, between that tween, right? Because as soon as you created, with something like TWEEN.js, it's like as soon as you created the tween, it's already figured out, based over this span of time, I've already calculated everything. I just need to know which variable you want while you're going through when you call the update function. So with something like that, it's like if you call like the same like delta time twice or multiple times in a row, it's like you're going to get back the same exact variables, right? And so if it's the same, then it's not going to really make any sense to run it again because you already ran it previously, right? So this kind of helps guard against that and makes sure that time is always moving forward whenever this is being called. And so you go into an InUpdate to kind of guard yourself. You figure out what the delta time is, and then you go ahead and pass that along in case you want to use it with any of the update functions, right? And then once all of that is done, then you call render, right? And you say InUpdate's false, so that update can get called again, and then you cast the previous time. Now, one of the things that you'll see here is that I'm not creating any new variables anywhere. You can see there's no lets, there's no consts, there's no vars, and there's a very specific reason for this. You've got to understand that like this thing is like being called a ton of times, right? And one of the things that can potentially slow things down is, one of the things that can slow things down is garbage collection, right? And so who here has not heard of garbage collection? Okay, so garbage collection happens whenever, so you create a new variable, right? So var foo equals like string, right? And whenever you create that, memory gets created within the browser and it gets held onto, right? If there's any references to that variable, it sticks around, right? Now, as soon as there's no other references to that variable and say that variable is set to null or undefined, it's not being used anymore, and there's no references pointing to it anymore, then the browser goes through a garbage collection phase where it goes and frees up the memory that it was previously using for that variable, right? And so there's absolutely no way to control that, and the browser does it on its own. And that was the same, like back in the day of Flash, everybody wanted like control of garbage collection, and the answer back then was that is something that is too powerful and dangerous to let the user control, right? And so it will go through garbage collection. The browser will go through its own cycle of garbage collection and just kind of go through and query everything that you've created and figure out whether or not it needs to free up memory. Now, there are times where it's like, oh, okay, you thought you freed something up, but something didn't get freed up, and then you end up with like a memory leak, right? It's like you go and you're doing performance profiling, and you see the little graph go up, and you're using more and more memory until your browser crashes and your computer crashes, and then your fans speed up really fast, and then you cry. And so it's like, that ends up being, the fact that it's like, garbage collection tried to run, you thought you freed up something, but, there was some reference somewhere that was still holding on to something that you just didn't think about. And so because this is going so quickly, I prefer to use properties like on a class and just to reuse those variables over and over again, right? Because a lot of these things, they're just either Booleans or numbers, right? And so as far as memory goes, it's like really on the back end, it's like all the compiler's doing is just changing pointers. It's like, oh, okay, you just created a new variable. Let me remove the pointer that was pointing to the old variable and just reinsert, right? Or it could actually be changing the actual value. It really kind of depends on the operation that you're doing. So really, nothing gets deleted until like the very end, right? It's like I normally, like PIXI.js has a destroy method that it has on the majority of, I think, anything that can go in the scene graph. So like any object that you can create has a destroy method. And, as a good citizen, it goes and tries to clean up everything that it's created, right? That's also a good place to also, like, remove event listeners and things like that. So, for the purposes of this, it doesn't really get called. It mostly doesn't get called. It's like, even here, it's like, dealing with, like, with hot reloading. So it's like I make a save, and the browser tries to re-inject the JavaScript. So every once in a while, it's like, it screams. It's like something's already been created or something, and then I just have to really refresh the browser. But here it's like I'm basically trying to see if destroy exists and just call it to see, just try to clean things up a little bit. So, so you can see like right here in the main application, I'm trying to remove events. There's one funny time where I was, with the map, I was going and I was doing a panning, like I did a small refactor, and one of the things that I forgot to do was removing the event listeners that I was listening to for all the mouse events. And so there was a weird thing that was happening in the instantiation of the application where the add event listener was being called, and then somewhere there was like a logic check that was happening that was calling it again, that was adding it twice, right? And then, and then the application was getting deleted once, and I was tracing it all through, and I was like, yeah, I don't really get what's happening. But I couldn't figure out why, like, whenever I was panning at twice the amount of what I wanted, and what was happening was that the event listener was actually added twice, so the one that was, the first one held, the first time I did the add event listener, it was holding a reference to the update functions, to actually, for the panning stuff, that didn't get garbage collected when I thought I garbage collected them, because I thought I removed the whole thing, but they stayed around because the event listener was still there, right? So even though I had called destroyed on my method, and I called, remove event listener, because I had called it twice, it still had some reference sticking around in memory. Took me a couple of days to find that one. That was a really retarded one. But always try to remove stuff if you can. But the moral of this story is I try not to use variables very much. I try to use property variables a lot of the times, because I don't want to worry about garbage collection. Because if, say, where's this update function? Say in this update function, right? I said, const, position equals this dot position, and say I did something to it. I say position dot x plus equals 20. Let's go 60. And then I pass in position, right? So it's over here, it's You can see it's kind of like off-center to like where I'm clicking. It's actually kind of weird and kind of cool. But you know, one of the weird things that's happening is that if I did this enough, and I keep doing this enough, this is actually dropping frames. Oh, this is the no buffer example. If I keep doing this enough, and you know, in this case, it's like a very simple object. If you keep doing this enough, you're gonna start incurring a bunch of garbage collection, which can start to slow things down, right? And so sometimes I kind of hate the fact that I am doing some of this stuff, like especially within where do like particles? It's like here, it's like in the actual like individual particle itself, it's like I've got all these extra variables that are only being used for the calculation of the position of the particle itself, right? It's, so I created a bunch of property variables, and so there's a bunch of underscored stuff because I don't want anybody to access them because, they're just internal and private. So, but, I kind of feel that it does help, right? It's like I could just as easily go and, just turn this, to a constant and just go through it, but it's the thing about it is like whenever you start to develop like larger applications and more complex systems, it's like, okay, well, you kind of get away with it in a couple of functions here and there, right? But then on requestAnimationFrame is like as this thing kind of keeps getting bigger and bigger and you start tacking on more pieces, and say you're working with a bigger team and everybody's starting to do it, right? Everybody's creating variables everywhere. You start to get to a point where it's like all of a sudden it's like, oh, wait, there's a performance drop. What's going on? It's like, and you're noticing that it's kind of happening like on the cycle, right? And so that cycle may be happening because, requestAnimationFrame's running, right? And then all of a sudden, it may run, like whenever you see that little graph in the upper right corner, that little green graph, whenever you see it running, right, it's sitting there, and you kind of see that it's kind of like on a bit of a cycle, right? Well, like you can't physically see on the graph every time requestAnimationFrame's happening, right? It's just too damn fast, right? And so what's happening is that, like every second or so, 60 of these requestAnimationFrames has happened. And the browser's like, okay, well, this may be a good time to go and do a garbage collection. Let me go and see if I can try to clean up those variables. So what you may see is like, when you're running your application, you do a performance profile. You'll see like you kind of see like a sine wave or like a square wave, right, of your memory just kind of going up, and then you'll see it kind of plateau from the memory that you created from a number of cycles, and then it drops again because the garbage collection happened, right? And you just kind of see it happening over and over and over again. And so. Yeah, so, for the most part, this is just a bunch of math calculation stuff. But here is some of the stuff that was happening on the janky side, because we're starting to kind of run a little bit short on time. So here it's like, like on the root of the application, it's like we're going and we're adding a bunch of event listeners for like the mouse down, mouse move, and the mouse up, right? And so... And those are all attached to these class functions. And so each one of them is basically checking to see if the engine's running. If it's not running, go ahead and start it. And, and then call update position and pass on the event object, right? So that we can actually figure out, like, what the position is. And let's see. And so the thing that sucks here, right? And let's see, it's mostly here on the mouse move, right? This guy right here, right? So this should capture. All it's doing is just guarding against. It's like, okay, well, once you add the mouse move, it's like it's always going to capture, right? But we actually don't want to update the position unless we press the mouse down, right? And so once you press the mouse down, then that allows you to go and say, all right, well, let's go ahead and update the position, right? And so what it's doing is that every time you're moving the mouse with the mouse down, it's like it's pummeling this update position function, right? And this update position function, it just sets the x and y property of position, and it calls update, and then update basically goes and tries to update the position of the particle, right? And you can see it's like, okay, well, it's like as I'm moving this, you can kind of see like around the edge of the circle. You can kind of see that, it's like the elements are kind of moving pretty fast, right? So visually, it's like, I'm kind of edging on like, it looks pretty damn good. But what's happening is that it's like I'm just getting at the edge where it's like it's starting to drop frames, and it's like, okay, I start moving this around, it's dropping down to like 56, 57, 59 frames per second, and this is on a pretty powerful machine, right? This is graphics processing right here. But you get a MacBook Air or something lower powered or something like that, or a mobile device, it's not going to work that well, right? And so, but one of the things that you will see that is being a good citizen, right, is that whenever it stops and it's not doing anything, it's not drawing anything, there's no sense of running requestAnimationFrame, right? You're just displaying an image and you don't have to do anything. And so at that point, the browser is literally doing nothing. It's just sitting there, displaying an image that it rendered in Canvas, and you're not using up any processing power. You're not using any CPU cycles or anything like that. It's just sitting there, waiting for something to tell it to render again, right? And that right there, that little thing right there kind of gives you a big performance boost, especially like when it comes to like mobile, right? It's like so I used to work at a startup called Famous, right? And one of the first demos that they had on like the early iPad with like the scrolling thing, it was all HTML and 3D and physics and stuff like that. They couldn't keep the iPad running for more than like 5 or 7 minutes before the battery drained because of the demo. And so in the back, they had like a whole array of like these iPads, and they kind of just kept bringing them out until they were done with the demo, and because it was just killing the battery, right? And that early version was just like it was just running requestAnimationFrame and just draining the battery, right? And it can happen really, really fast. There's been some really great talks about like performance in mobile and stuff like that, and how the CPU, like which CPU and which GPUs decide to turn on and turn off at certain times, and who's doing what type of calculation when, and things like that. And so it's like you only have so much that's in your control, especially like when you're dealing with WebGL, right? It's like you don't want to think that it's like, hey, it's like I can draw like all this cool stuff with like PIXI or 3JS or like whatever the case may be, and I can go and just throw all this stuff at this machine. It's like, well, like when you start hitting mobile devices, like you're going to start to see that your battery life going slower and slower, and getting less and less and less, and then or it's like in my case on a daily basis when I'm screwing things up, it's like my fans always spin up on my MacBook, and it's like when that happens, it's like I know I'm doing something wrong. But let's see. But yeah, so like this is kind of like the big case right here, right, with this mouse move. Now let me switch over to the non-janky version real quick. Okay, so this is the same like entry point. All I'm doing is that on the mouse down and mouse move, I'm listening to the same thing, right? And so basically all I'm doing is just starting the engine. Don't really care, right? And there's just a single update function, right? And so where it gets all the goodness from is this position buffer, right? And the position buffer is kind of a separate class, and all it does is basically the same logic that I just showed you before. It's got the event listeners for the mouse down, mouse up, and mouse move, and really all it's doing is just calling this update function, right? It's like I'm checking to see if I should capture something. On mouse down I set it to true, on mouse up I set it to false, and then I just call this update function. And the update function, all it's doing is just storing those variables. It's just buffering it out, right? And then I underscored it because I only wanted to allow people to get the X and Y variables instead of setting them. And so based off of that, then it's like I can go and just grab the position from the position buffer. Every time update gets called, an update gets called on every tick of the engine only. And I think that is pretty much about it. So the only last thing I have to say is if anybody is interested, and I'll show this real quick. We are hiring. We are hiring. And if you want to fool around with stuff like this, you can hit that link, send me an email, and feel free to ask me questions. But it's not just my team that's doing it. It's like we're hiring across the board, engineers. So yeah, thank you.